Welcome back. The goal of this presentation is to examine the characteristics of the various lunar calendars and the associated Metonic cycles which have been discovered. These were revealed over the previous two parts. They are not just random numbers. There is a mathematical relationship at play, not just internally over the 19-year pattern, but each is tied to a particular environmental condition which results in the special characteristics of the particular calendar. This is something that is not common knowledge. In my research over the past 15 years, I've not come across anyone who has realized this. Or if somebody has, it has not been made widely known. This information is very significant because it can be shown that the modern Jewish calendar should not be relied on for accurate historical dates, especially before 350 AD. Fair warning, this will be a more technical presentation. Discussing calendar rules and showing calculations must be done in order to prove the mathematical relationships at work. This is most likely why more people are not aware of this information. They have not taken the time to explore the mathematical relationships. I hope that by the end you will see why all the technical discussion was necessary. I won't go over too much detail in review. The previous two parts laid out the basic operation of the Luni-Solar calendar. This means that the calendar is both tied to the lunar cycles and to the solar cycle. 12 lunar months is 11 days short of the solar year. Over several years, the start of the lunar year would slip earlier in the seasons. In order to keep the seasons synchronized, every 2 to 3 years, an extra month is added. This is done around the time of the spring equinox. Traditionally, the start of the year for various Middle Eastern cultures was the spring and was tied to religious festivals. In particular, Passover is one of the 3 spring festivals of the Jewish calendar. The pattern of adding these additional months forms a 19-year cycle. The previous presentations revealed that there are several Metonic cycles which have been in operation over the millennia. Each is a 19-year cycle. However, the start of each cycle is anchored to a different year. Viewing the chart, it might look like just a random order. However, that is not the case. The fact that these different cycles exist is not at all common knowledge. The reason why these patterns look like they do is even less well understood. When I first came across the historical documents which described the various Metonic cycles, there was the initial shock that they even existed. I had thought that different Metonic cycles should exist, and that was what prompted me to do the initial research to begin with. However, when I found them, I was left with the task of how to verify that this was trustworthy information. I too thought that this was just anchored randomly. What I decided to do is put together a thought experiment for each different type of calendar. I chose a set of ancient years and considered the rules that were specific for each calendar. Since every new month is tied to each new moon, the beginning of each year could be determined. The pattern of additional months would reveal themselves over the course of the range of years. What I needed was information about historical dates of the phases of the moon. Phases of the moon have been very accurately determined going back millennia and are available. So armed with these dates of each new moon and the rules for the calendars, I started charting out what would be the start of each year in the range I had determined. But before we get to the math and the charts, we need to determine the rules for the start of the year for each type of calendar. The rules of the modern Jewish calendar were codified by Hillel II around 350 AD. The beginning of the religious year, the month of Nisan, was determined by something eventually called the rule of the equinox. In the Talmud, the Jewish religious commentary, written at about the same time, the instruction was given, "When you see that the cycle of Tibet extends to the 16th of Nisan, declare that year a leap year, and have no scruples, since it is written, 'Observe the month of Abib,' which signifies, 'See to it that the Abib of the cycle should commence in the earlier half of Nisan.'" This needs some explanation. First, the 16th of Nisan. Nisan is the first month of the religious year and contains 3 of the 7 main festivals of the year. The 16th of Nisan is important because that is the day of the month that a particular ritual took place which was tied to springtime agriculture. The cycle of Tibet is another term for the winter season. That meant if winter extended past Nisan 16 without the spring equinox occurring yet, that meant that the festivals were happening too early in the year. That year should add an additional month, and the festivals would happen in the following month. So in other words, if Passover would happen before the spring equinox, then add an intercalary month that year. But when exactly is the spring equinox? We are used to the dates of March 20 or 21. However, that is in the Gregorian calendar, a calendar which came into use in 1582 AD. Before that, the Julian calendar was in use, and the equinox occurred on March 25. Over the centuries, due to the slight inaccuracies of the calendar had shifted those several days. It is important to keep the various calendars in mind when working with historical dates. So instead of March 21, we will use March 25 Julian date for the spring equinox rule. Next, let's discuss the New Year rule for the ancient Babylonian calendar. This calendar was in use around 600 BC and lasted until at least 75 AD in the modern area of Iraq and Iran. According to Stern, in his book Calendar and Community, the rule to begin the new year was the first new moon after the spring equinox. Their New Year festival, a spring rebirth called Akitu, must happen after the equinox. It is very interesting to observe the historical record of when years actually began, which is found in the Babylonian Chronology. You will notice that most years begin in April. This verifies the rule of the first new moon after equinox was in place during this time. The Jewish calendar was not always a fixed calendar. It was originally based on observations of the new moon and of the state of the barley harvest. During the era of the Second Temple, circa 530 BC until 70 AD, the Great Sanhedrin oversaw the decisions for the calendar. They would hold a special court called the Bet Yatzek on the 30th day after the first day of the month. They would declare the start of the new month based on the testimony of 2 witnesses. These witnesses would give evidence that they had seen the first sliver of the moon's crescent after the new moon phase. The new month was decided at the phase of the new moon when the earth, moon, and sun are in line. They were in conjunction. However, the actual phase of the new moon could not be seen, so they had to wait until they saw the very first signs of the moon's light after this phase. Since the lunar cycle is 29.5 days long, a month could have either 29 or 30 days. They met on the 30th day and heard from any available witnesses. If the witnesses were credible, then that day was declared the first day of the new month, the previous month declared as having 29 days. If there were no witnesses at that time, then the next day was declared the first day, the previous month declared as having 30 days. The religious leaders also decided on the beginning of the new religious year. This was very much tied to the state of the ripeness of the barley. One of their 3 spring festivals, called First Fruits, depended on having ripe barley available for the priest to do a wave offering, that is, lifting up the first ripe barley before the altar. You shall bring the sheaf of the first fruits of your harvest to the priest, and he shall wave the sheaf before the Lord, so that you may be accepted. On the day after the Sabbath, the priest shall wave it. And this is found in Leviticus 23:10 and 11. Only after could the population begin to harvest and enjoy the new crop. Since this festival happened in the middle of the month, if they didn't observe green heads of barley in the fields at the beginning of the month, they knew that there would be no ripe barley available as needed. This is when they added an extra month, which would give the barley enough time to ripen and be ready for the required festival. So let's talk about the life cycle of winter barley. Barley has a particular life cycle which is tied to the sun. It is this intersection of solar along with lunar which gives the calendar based on observation its unique character. There are two types of barley, summer barley and winter barley. Winter barley is planted in the autumn and is the earliest maturing grain in the springtime. It is known to be the fastest growing of the winter grains, with roots traveling over 6 feet deep in the ground. This type of barley can handle both weather and soil extremes, having the highest soil salinity and pH tolerance of all the cereal crops. It is not just that winter barley can survive colder winter weather, but it requires it. There is a period of vernalization. This is one of two internal switches which must be flipped on in order for the process of flowering and the production of grain to start. The second switch is what is called photoperiod. Barley is a long day plant, having a requirement for a certain number of daylight hours. The plant starts its growth phase in vernalization, waiting for a certain number of cold hours to have been met. During this time, it hugs the ground with a very flat growth habit. Its growing tip is near the soil surface, which reduces the risk of damage from this period of colder weather. Once the required number of cold hours have been reached, it enters a phase where it is affected by the length of day, waiting for a day with a certain number of daylight hours. When this is met, the reproductive phase switches on and the rate of development drastically increases. After meeting these two internal requirements, the barley enters a 2-week optimal flowering window. In Israel, located at roughly 31 degrees latitude, wild barley flowers for a 2-week period in early to mid-March. Just 10 degrees further north, that is, for example, in Spain, the winter barley flowering occurs in mid-April. These particular characteristics of barley can be relied on as an extremely precise calendar trigger point, which is specific to a relatively small geographic area. After flowering, 2 phases of grain development begin: cell division and grain filling. Cell division starts after the fertilization process and continues for 14 to 30 days depending on the variety of barley, the environmental conditions, and the position in the head of grain. The process of grain filling begins 5 to 10 days after fertilization and continues until the grain is fully ripe and depends mainly on temperature and moisture conditions. Physiological maturity occurs between 40 to 50 days after flowering. This would be from about mid to late April. The outward sign of green is a loss of green coloring, and the grain's loss of moisture is very rapid during this stage, the period of optimal barley harvest. However, barley is still harvestable a few weeks before this time as well. The seed embryo development inside each grain is complete roughly 25 days after flowering, on average shortly after the spring equinox. The photoperiod requirement is extremely important in determining the start of the plant's reproduction phase and when Abib barley would occur. Although weather and environmental conditions have a part to play, it is this internal switch that determines the flowering phase based on the amount of daylight hours experienced. This requirement is consistent and predictable every year as the short days of winter gradually lengthen, approaching the longer days of spring. The result is a relatively short time frame of 2 weeks, occurring on average 2 to 3 weeks before the spring equinox. Formation of green ears of grain would be evident immediately following, around 1 week before the spring equinox, the barley being in a state of Abib. This is a possible explanation of why the vernal equinox rule would have been specified in the rules for the modern calendar. When observing the winter barley growth cycle, it is consistent with Abib occurring around the time of the equinox. However, the significance must have been forgotten over the centuries, since the observation of the barley harvest could no longer occur after the destruction of the temple in 70 AD. Eventually, it was the date of the Passover which was associated with the spring equinox, not the state of the barley harvest. The main purpose of the biblical instructions is that there should be harvestable barley by the time it was required at the first fruits offering. It is this connection with the state of ripeness which gives the observed calendar, or Abib calendar, its unique characteristic. Let's move on to the mathematical proof of the various calendar Metonic cycles. I will show you where all the source information comes from, and I encourage you to take the time to do these same calculations for yourself. Take a different range of years and see if the same relationships reveal themselves. First, for a range of years, we need to determine the dates of the new moon. Remember, each new month is tied to the new moon phase. Since we are interested in the spring equinox, which is March 25th in the Julian calendar, we really need only a month or two before and a month after the equinox. In this presentation, we'll consider the 19-year period between 21 AD and 40 AD. This is the lunar phase information which has been calculated for several millennia by Fred Espenak. For each year, record the range of dates of the new moons. Next, put in the associated Jewish year number. You have to remember that even though we are interested in the beginning of the religious year in the springtime, the start of the civil year and the change in year number happens 6 months before in the fall season. Now we will go year by year and apply the new year rules for each calendar and see what happens. First, take the year 21 AD, which is 3781 AM, the Jewish year. The new moon phases occurred on February 1st, March 3rd, April 1st, and May 1st that year. We'll consider the calendars in the following order: the Babylonian calendar, the modern Jewish calendar, and the Jewish calendar based on barley ripeness. We have discovered that the Babylonians started their year on the first new moon after the spring equinox. Since March 25 is the equinox in the Julian calendar, the first month after would start on April 1st. The modern Jewish calendar has the rule of the equinox that if the Passover on Nisan 14 would occur before the equinox, then add an extra month. So adding 14 days to March 3rd would be before March 25. So the new year would occur on April 1st. The Jewish calendar based on barley ripeness needs to take into account that the green ears of barley show up around the equinox and then require at least 2 to 3 weeks further to ripen. So April 1st would be the start of the new year in this calendar. Moving on to the next year, 22 AD or 3782 AM, We know that a 12-month lunar year is 354 days long and is 11 days short of a solar year. Looking at the previous year, the new year happened on April 1st. 12 lunar months later, and roughly 11 days short, a new moon occurred on March 22nd. Is this when the new year would happen this year? Let's apply the rules for the calendars. The modern Jewish calendar, first of all, the Babylonian New Year must occur after the spring equinox, so March 22nd is too early. The next new moon is April 21st, and so an extra month is added for that year. The modern Jewish calendar requires that Nisan 14, in the middle of the month, happens on or after the equinox. With March 22nd as the start of the month and going forward 14 days, that is well past the equinox, and so it works out. The Jewish Abib calendar requires barley ripeness 2 to 3 weeks after the equinox. With March 22nd as the start of the month, this does allow for 2 weeks after the equinox for ripe barley to be present. For this year, only the Babylonian calendar requires an extra month to be added. The other two calendars do not. The next year, 23 AD, or 3783 AM, has new moons on February 10th, March 12th, April 10th, and May 10th. All 11 or so days short of the previous year. The previous year had the Babylonian calendar start on April 21st. 12 months later, the year would start on April 10th, which is after the equinox. This satisfies the calendar rules. For the modern Jewish calendar, 12 months from the previous year falls on March 12th. Would the middle of the month occur on or past the equinox? Yes. March 26th is just past the equinox, so the year would begin this month. The Abib-based calendar rule takes into account 2 to 3 weeks of ripening after the equinox. Would March 12th allow this? No. The middle of the month would put it right around the time of the equinox. An additional month is required to provide time for ripe barley, so the new year would begin on April 10th. For this year, both the Babylonian and Abib-based calendar start in April. The modern Jewish calendar would start in March. Now consider if you wanted to know the equivalent date of Nisan 14 in the Julian calendar. Which Metonic cycle would you use, and which is correct? The modern Jewish calendar came into use around 350 AD. Can it provide accurate dates for this particular year of 23 AD? If the Jews were using an observation-based calendar and needed ripe barley, then the modern calendar rules lead to an inaccurate date of sometime in March. The Abib-based calendar has an extra month pushing the actual historical date into April. This is what has not been recognized by scholars for centuries. This is why many accepted dates which use the modern rules to determine the equivalent dates are simply wrong and must be re-examined. But we're not done yet. We've only gone 3 years, and there's more amazing realizations to come. The next year is 24 AD, or 3784 AM. The new moons happened on January 31st, March 1st, March 30, and April 29. For the Babylonian and Abib-based calendars, 12 months later would be March 30th. This is after the equinox and satisfies the rules for both. The modern Jewish calendar is looking at March 1st as a potential start of the year. However, 14 days later and a March 15th Passover date is well before the equinox on March 25th. Therefore, an extra month must be added. This calendar's new year would begin on March 30th too. The following year is 25 AD, or 3785 AM. Here, 12 months from the previous year is March 18th. Even though it is before the March 25th equinox, the modern Jewish calendar rules are satisfied and the Abib-based calendar rules are also satisfied. but the Babylonian calendar must add an additional month in order for the start of the year to occur after the equinox. (26 AD or 3786 AM is next. For March 8th, the modern Jewish calendar rule of Nisan 16 occurring on or after the equinox is satisfied. However, the Abib-based calendar must add an additional month in order to provide 2 to 3 weeks after the equinox. The start of the year gets pushed to April 6th along with the Babylonian calendar. For 27 AD or 3787 AM, the date of February 26th is much too early for any of the calendar rules. They all start on March 27th, and the modern Jewish calendar having to add an additional month in between. We arrive at 28 AD or 3788 AM. 12 months later is March 15th, which satisfies the requirements of the modern Jewish calendar, which provides for Passover after the equinox. However, the Babylonian calendar must begin after an extra month on April 13th. The Abib-based calendar also requires an extra month to provide for the ripening of the barley after the equinox. (29 AD or 3989 or 3789 is next. Here again, 12 months later, on March 5th, the date is too early to satisfy any of the rules of the various calendars. An extra month is added for the modern Jewish calendar, and all new years start on April 3rd. The next year, 30 AD or 3790 AM, has a 12-month span end on March 23. Both the modern Jewish calendar and the Abib-based calendar rules allow for the year to start here and provide for the Passover to occur properly. The Babylonian calendar requires an additional month and so starts on April 22nd. The following year is 31 AD or 3291 AM. 12 lunar months later is March 14th. The modern Jewish calendar satisfies its rules to have this as the start of the year. However, the Abib-based year will not have evidence of green barley ears for a couple more weeks when the equinox occurs. Therefore, an additional month is required and will set the start of the year on April 12th. In the middle of the month, Passover would occur on April 25th that year. For those that can see the significance, this date has been hidden from history for many centuries already. In 32 AD or 3792 AM, 12 lunar cycles later occurs on March 3rd. This date is much too early for any of the calendar rules, and so the modern Jewish calendar requires an extra month to push the start of the year to April 1st. The following year is 33 AD or 3793 AM. The March 21st date as the start of the year satisfies the rules for both the modern Jewish calendar and the Abib-based calendar. Since the equinox has not happened, the Babylonian calendar requires an additional month and starts on April 20th. We're getting to the final stretch. Again, this might be tedious to go through, but each year needs to be considered against the calendar rules in order to determine the start of the year. What we will see as a result will shock you. For 34 AD or 3794 AM, March 10th still fulfills the requirements of the modern Jewish calendar. But the Abib-based calendar requires an additional month to allow for barley ripeness after the March 25th equinox. The start of the year occurs on April 8th. In 35 AD or 3795 AM, the March 29th date for the new year meets all the requirements of the various calendars. Let's consider 36 AD or 3796 AM. 12 lunar cycles later is the date of March 17th. The rules for the Babylonian calendar specify an additional month pushing the start of the year to April 16th. But for the modern Jewish calendar and the Abib-based calendar, March 17 does meet the requirements for their rules. In 37 AD or 3797 AM, the March 6th date does not allow for ripe barley for the Passover, so an extra month is required for the Abib-based calendar. For 38 AD or 3798 AM, all calendars have rules that allow for March 25th as the start of the year. In 39 AD or 3799 AM, March 16th is the start of the year for the modern Jewish calendar rules. However, the Babylonian calendar needs an extra month in order to start after the equinox. The Abib-based calendar needs to allow for several more weeks of barley ripening. Both of those start on April 14. And last, 40 AD or 3800 AM, has April 2nd as the start of the year for the Babylonian and Abib-based calendar. March 4th is much too early for the modern Jewish calendar, and so an additional month also pushes it to April 2nd. At last, we're done. Now let's examine what has been revealed. We have taken a 19-year range and have determined which years require an additional month. Each calendar has a different criteria for when an extra month should be added. If we list where all the extra months occur for each calendar, we can put together a list of years within the 19-year cycle. For the Babylonian calendar, we construct a list, and for the modern Jewish calendar, and also for the Abib-based observational calendar. Now let's take these three lists and compare them with the Metonic cycles that have come from ancient documents. Do you notice anything? Each of the calculated cycles that we have just constructed match the Metonic cycles that have been recovered from the ancient documents. They match exactly. These cycles are not random. Here is the mathematical proof for where they are anchored in the 19-year cycle. Each cycle depends on a particular relationship with the spring equinox. This gives them their unique pattern. I know this might have been long and tedious, but it was required. I don't know of anyone who has actually worked through an entire Metonic cycle for these various calendars before. Not that I've come across anyway. And it was a necessity in order to compare the results with that of the historical documents that have been examined. There are some very important conclusions that are now evident. The first is the realization that Metonic cycles are not randomly generated. A calendar with particular rules regarding how a year should begin results in a particular Metonic cycle pattern. We have seen 3 different calendars with 3 different rules of starting the year. That is why 3 different Metonic cycles have been generated. Second, the modern Jewish calendar is tied to the equinox rule. That is, Nisan 16 should occur on or after the spring equinox. This particular rule was officially codified after 350 AD and no earlier. Therefore, the use of this particular Metonic cycle to determine accurate historical dates before that time is not mathematically supported. This was not how the calendar functioned during the Temple era. Any historical dates which have been accepted as historical fact should be re-examined according to this new evidence. Third, during the many hundreds of years of the Temple era, the calendar was based on observation. In particular, the state of the barley harvest, or that of Abib. Based on the fact that barley has a small window of flowering and ripening that is tied to the particular latitude of the Jewish homeland, and that ripening starts around the time of the spring equinox, the unique Metonic cycle that results is evidence that it was the proper Metonic cycle to use for the Jewish calendar. It fulfills the requirements laid out in the Jewish scriptures and matches all the historical evidence of how the calendar operated during that period. This Metonic cycle should be used in determining accurate historical dates during this period. And the final conclusion is that the Abib-based calendar should be the method in use today. The modern calendar rules have strayed from the original intention of how the calendar should be maintained. We have seen that an entirely different Metonic cycle has resulted, which shifts the start of the years around. Only by using the Metonic cycle which results from the state of the barley harvest does the calendar maintain its correct relationship with the spring equinox and the proper harvest timing. Obviously, these conclusions have far-reaching implications. The entire system of a nation's calendar construction has been mathematically shown to be flawed. The other major implication is that historical dates which have been accepted as accurate are now questionable. Many of the problems that have been identified through the years could very well be solved by re-examining them with the Abib-based Metonic cycle. Many prophecies found in Scripture which have been consistently problematic should also be re-examined to determine the effects from this new research. Further presentations will delve deeply into these areas because this has only been the foundation of what has been discovered.